Ladies and gentlemen, very big welcome again to ICT712 Information Technology Project Management. Today I'm going to go and be talking about Chapter 9, which is basically relating to our Lecture 5. It's one of the main calculation chapters that I'm going to go and be covering. We are also going to be covering a non-calculation chapter that is also important. But there will be definitely a lot of calculations going to be in your exam. Yeah, I've already set up the midterm exam paper, and you need to really know every single calculation we went and we covered to you so far in the course. So any of the exercises I'm giving you, I'm always publishing the answers on the internet. I usually put them for you guys around Sunday night so that you guys will have the chance to be able to go and check the answers that you guys have went and inserted. So continue doing that, and let's try to go and help you to go and get the best outcome. Now, we've been going through week after week to talk about so many various topics. We spoke about the introduction, then we went to strategy, then organization, then we spoke about defining the project, and then we spoke about how we're going to go and estimate things. We spoke about building the network diagram. We spoke about schedules, resources, and cost. And today we can talk about the duration, how we are going to go and be reducing the duration of whatever items we are actually going to be working on. So the activities we need to go and be working on, sometimes there are reasons why we need to go and try to reduce how much things actually go and cost us. And this chapter is basically focused on that particular topic. How do we reduce the duration? What sort of things do we look at? What role does the costing really play? What do we do if it's a resource constrained project? What do we do if it's a non-resource constrained project? Like, we try to go and think about all of these various options to be able to go and really reduce the duration of our project. Now, we're going to understand the different reasons for crashing a project today. We're going to identify the different options for crashing an activity when a resource are not constrained. We're going to identify the different options for crashing an activity when resources are constrained. We're going to determine the optimum cost time point in a project network. We're going to understand the risks associated with compressing or crashing a project. And we are going to go and identify different options for reducing the cost of a project. This is basically in terms of the first chapter I'm going to be covering today, a chapter that is definitely going to be one of the chapters that could be coming in your midterm exam next week, and could also be coming in your final exam. So it's very important to really learn those calculations and know how to go and really apply them. Now, ladies and gentlemen, in very simple words, time is money. And a lot of times we want to try to go and, either reduce the time to save money, or if things are going to be taking longer than we are expecting, then things are going to simply go and cost me more money. So we need to go and try to find a way to be able to go and manage the costing that associated with my particular project. So when I talk about the reducing the time, we often talk about reducing the time of a critical activity. The reason why I talk about reducing the time of a critical activity, because any activity that is critical means it is an activity that is on a critical path. If I don't actually go and reduce the duration, if I want to reduce the duration of my project, the first thing I need to do is I need to go and reduce the actual duration of that activity that is on a critical path. That's the first thing I need to go and bear in mind. But when I'm trying to go and reduce the actual time of a critical activity, it actually means that I'm trying to go and get things done quicker. If I'm trying to get a job done quicker, it actually means I am actually assigning more people to a particular task for a task to be able to go and be completed quicker than we basically go and actually anticipate. So that's something to really for us to be able to go and bear in mind. When I talk about, we talk about direct cost reduction, we talk about indirect cost, and I'll explain the difference between this very shortly. But cost time solution focus on reducing the activities on the critical path to shorten the overall duration of the project. And that's something we're going to focus on about in a much more detail today in all of these calculations. Now, there are many reasons why we have what we call an imposed project duration dates. There are many reasons why something has to be done by a particular period of time. A lot of time, there's time to market pressures. If you don't finish something by a certain time, it actually means that someone else is coming to actually come and take a bite out of your market share. This is basically something that means it's going to go and make you lose a lot of money, something you really would like to go and actually avoid. Unforeseen delays. Sometimes you might be working on a project and you didn't expect that there is going to be coronavirus. And the coronavirus came and it affected everything you're doing. And now you say, you know what? I didn't really foresee that delay. It's something unforeseen. And I need to go and try to find a way to be able to go and finish now the project as quick as I can, bearing in mind all of that particular issue. Other things to go and bear in mind, incentive contracts. Sometimes, if you finish things earlier, you're going to be able to go and get much more money than actually finishing something later. I remember there was a case study I've read a long time ago. It was relating to the San Francisco bridge, which basically was destroyed as a result of an earthquake in the area. And what happened is that was the main freeway that was connecting the whole city together. So the amount of incentive that was actually offered for the job to go and be completed quicker was actually immense. People paid a lot of money for that job to go and really be completed quicker. And they did complete it quicker to be able to get that bonus. Impose deadlines and contract commitment. You might say, well, the project must be finishing by a particular time. If it does not finish by a particular time, then we're basically going to go and have issues where people are going to complain, the outcome wasn't being achieved, and so on. So a lot of times, if you don't finish by a particular timelines, it actually have a direct impact on your cost, because sometimes there are very, very big penalties associated with a job not being finishing on time. So it could be $5,000, $10,000 every day you delay the completion of a project. There's a very, very big cost associated that someone have to go and pay, and a lot of time it means a company will have to go and pay that particular costing. Otherwise, they won't be able to go and get their money. They have to go and pay the cost of getting things done later. Other times is what we call overhead and public goodwill costs. If I go and overhead, if for example I am renting space, and if I finish quicker, I'll be able to go and save that money that I'm using on that space. That would be a very big advantage that some people would say, I would like to go and benefit from. Other times it could be, public goodwill cost. We want the public to go and be happier with what we go and deliver. If we deliver it quicker for them, they will basically have that, appreciation. Pressure to move resources to other projects a lot of time is a big issue. Like if I don't actually go and finish quicker, I can't actually start any other projects, and there could be some projects that are very important strategically to my business, for my business to really go and be successful. So another thing I really need to go and bear in mind there. Now, you need to bear in mind that nothing is for free. So if I'm going to go and try to finish things quicker, it's going to basically mean, something have to give. It's going to go and, cost me more, higher cost, lower quality. And a lot of time you might even have what we call, client dissatisfaction. If you're going to go and actually, pay more money, they might say, you know what, I'm not happy with the fact that now you actually charge me more money because the project wasn't actually finished within the timeline that we actually expected that to go and really be completed. So things to really go and bear in mind in that particular perspective in terms of what we need to go and do. Now, when I talk about trying to go and finish something quicker, we talk about, different type of sort of projects. We talk a lot of time about resource constrained projects, and we talk about, non-resource constrained projects. If I say about resources, if I don't have a constraint in terms of how many resources I am actually able to go and use at any point of time, what that would means in simple words is, if I go and find that there's a problem with my project, the very easy and simple thing for me to go and do is let me go and actually add more people. By adding more people, I am able to go and really solve the problem. and that basically will give me the outcome that I would like to go and get. If I have no resource constraints, I could go and say, let me go and outsource my project work. I would say, let me go and give it to another company, to another supplier, to whoever, and they'll be able to go and do that particular side of the work for me. I can go and say, let me go and schedule people to go and actually work overtime. And that's going to mean, yeah, it's going to cost me more money for the overtime people, but at the end of the day, I'm going to be able to finish the project quicker. Let me establish a core project team, and that relates to what I've covered previously with you guys, explaining to you that there are different type of structures in project management. I said there's a metric structure, there's a the functional structure, and there's a dedicated project structure. So when I'm putting here a dedicated project team, I go and ask myself, my question, but what am I going to go and achieve from actually getting that team to go and be working? Another option that sometimes is used is what we call a do it twice, fast, and then correctly, which means you do the job first. It's not going to be the best possible quality outcome there, but you're still okay with doing that outcome, because at least you know that you're trying to get the job to go and be completed. But then this next time you go and say, okay, now I'm going to go and fix all of these mistakes. I know I've done it quickly. I know it had issues. Let's say you do the software very quickly. You don't do a lot of testing, and it's going to be a problem, but you want it to go and deliver it quickly. And then after that, you go and start, make all the rectification of the problem of that would otherwise basically not have been completed. So that's another approach we go and think about. That is if my resources are not constrained. In other words, I can add as many people as I want with no issues whatsoever. I can really go and follow that approach. But a lot of time, my resources are constrained. And when I say my resources are constrained, it really relates back to what I spoke to you last week. If you don't have enough resources, you see how some tasks which might be able to go and be done on a parallel time at the same time might now have to go and become done in a sequential manner, one after the other. So that's something to go and really bear in mind in terms of how are we going to go and really do the job that is really required. So fast tracking is really about rearranging all of these network logic. Let's go and maybe if we can, let's make some things at the same time if we have the resources available. But sometimes, let's go and, try to use a lot of this Slack that is available. And that Slack means I could make some delays for some items and still be able to go and finish the project as quick as I can. Critical chain means let me focus solely on the activities on a critical chain, and how am I going to go and ensure that those particular activities are not going to go and take longer than what is required for the job to be done. Reducing the project scope is the easy one. Let me go and give you less things and then I'll finish quicker. Yeah, of course, but that's not what I want. I don't want you to finish less things. I want you to finish more things, but that's just one thing to go and really bear in mind there. Compromising quality. You're going to get the lowest quality for people, and not necessarily the best outcome, but sometimes, people might accept that there's going to be we're going to compromise quality to finish things quicker, because we simply don't have resources. If I go and say I'm assigning you 10 people, the result is going to be different and quicker and better than me assigning, I don't know, maybe 5 people to be able to go and work on a particular project. So all of these are various things we need to go and bear in mind in terms of resources versus non-resource constrained projects. So when I talk about, the resources constrained versus non-resources constrained, we talk about costing. We talk about it actually costs me money. Every time an activity takes longer to complete or take less to complete, it is going to actually cost me money. So the first thing I need to go and do, okay, what am I going to go and be doing so that things won't actually end up costing me a lot of money and making me actually go and lose? So what do? We go and look at the indirect costs and a direct cost. Now, what an indirect cost? It is a cost that cannot be associated with a particular work package or a particular project activity. For example, you might have supervision for employees, but that supervisor is not actually doing the job. That supervisor is simply doing what a supervisor is supposed to do, supervising the people to ensure the outcome that needs to go and be delivered has actually been delivered. That's what you call in terms of the supervision. Administration, you might have people who need to go and do admin, accounting, and so on. This is an indirect cost. It's really basically related to the project, but it's not to an activity. For example, if I'm going to go and have the project for a year, I'm going to have to pay administration costs for a year. I'm going to have to pay consultants for a year. But if the project goes and finish in 5 months, I'm only going to have to pay administration for consultant for a period of 5 months. So it's indirectly, they don't do an activity, but it's indirectly related to the project. Interest, if I borrowed $1 million, the $1 million is not making an activity on a project, but it is still a cost that we need to go and bear in mind that will actually influence the outcomes I'm going to go and be achieving for my project. So again, that's something that you need to go and really bear in mind. There are costs that vary with time. So if I go and actually reduce the project time, so if the project will finish quicker, the indirect costs will also go and reduce. It's basically they have that relationship that we need to go and simply bear in mind. Direct costs are normal costs that can be assigned directly to a specific work package or a project activity. I'm having a labor for an activity, I'm having a material for an activity, I'm having an equipment, I'm having subcontractors working on activity. They're all what we call direct costs because there are people working specifically on work packages or project activities to be able to go and get the job done. Labor, materials, equipment, subcontractors, to name a few. Crashing activities. If I'm going to try to finish an activity quicker, I'm going to try to crash the activity, which means I'm trying to go and actually assign more people potentially to that activity, or more materials, or more resources, or more subcontractors to that activity. And the purpose for me doing so is I am trying to go and finish that activity quicker than I would otherwise go and actually go and finish it. And if I'm trying to finish it quicker by throwing at it more resources, it is going to go and actually, cost me more money. Because if I'm going to go and put, employ Fadi overtime, I'm going to have to pay them double. If I'm going to go and put a second worker with Fadi, I'm going to have to go and pay the second worker. So whatever you do, you're actually trying to go and, increase your direct cost. If you increase your direct cost of doing that activity, you're going to finish the activity quicker. So your indirect costs will decrease because, let's say administration, I need 1 day less cost of administration, but your direct cost for the project is going to really go and be increasing. And that's something we need to go and bear in mind. Any questions so far, my friends?
All good.
Alrighty, matey. No problem. Let's continue. Now, we often try to go and construct what we call a project cost duration graph. So what we try to do, we try to show our costings on a graphical manner. So we say, okay, what is my total direct cost? And what is my total indirect cost? So let's say I say my direct cost is $100, my indirect cost is $100. So my total cost becomes $300, $200 for both the direct and indirect cost. So what you do, you basically add the direct to indirect cost for every period. So you might say period 1, it's going to cost me 200. Period 2, it's going to cost me 200, 300. Period 3, it's going to cost me 400. Periods 5, it's going to cost me 50. So you compare, you basically add your direct cost, you add your indirect cost, you combine them together, and that will tell you what is the total cost that you are going to be incurring if your project was to go and finish at a particular duration. So that's what we need to really go and bear in mind here. How are we going to go and reduce the overall costing that is really associated with a particular project. So we need to go and compare them to be able to go and get that reduction. Now, how do we choose what do we reduce? Well, we need to determine activities to shorten. There's 20, 30, 40, 50 activities on your project. You need to know which activities am I going to go and shorten. And the way you basically decide is you shorten the activities that are going to have a smallest increase in cost per unit of time. In other words, I'm going to go and try to reduce my activities by seeing which activity, if I reduce, will reduce my project, but at the same time will minimize the costing that I am going to go and be incurring at any particular point of time. We have to make many assumptions. We make the assumption that cost in a relationship is linear. So the cost is going to go and be increasing every time we're going to go and, try to, reduce the actual duration of the project. We talk about normal time assumes low cost efficient methods to complete the activity. So normally, which you're going to hear a lot about normal time and normal cost. Normal time, it's normal time, the normal cost efficient method for us to complete the project. Crash time represent the time, represent a limit, the greatest time reduction possible under realistic conditions. So what is the cost is going to go and be? What is the, the crash time, the greatest time reduction I can go and reduce my project overall by actually also minimizing my costing at any point of time. We need to calculate things called slope, which basically represent a constant cost per unit of time. In other words, every time I am going to reduce a activity duration, what cost am I going to go and pay for that particular reduction at that point of time? And we basically have to go and bear in mind that all acceleration must occur within the normal time and crash time. In other words, normal time for an activity could be 4, crash time might be 2. So you can only reduce 2 periods for that particular activity. Every acceleration must occur within the normal time and the crash time of any particular activity. I'm going to make this exercise, but I want to just contact the people who are not in the class personally. So I'm going to just pause the recording for a minute. Now, ladies and gentlemen, I want you to go and look at what I'm showing you here. In front of you, you basically see a table. And that table have something. That table basically have what we call a normal time and have something called crash time. So it's about really understanding what is a normal time, what is a crash time. A normal time means a normal time, it's usually going to basically be taking me to go and finish a particular activity. So let's say I say a normal time for activity A is 3 days, means under normal circumstances, this activity will go and take 3 days for it to go and really be completed. The crash time of 2 days mean this activity, if I decide to go and really crash it, it is going to go and actually take longer. It's going to go and finish quicker if I am going to go and crash that activity. And the crash time is what I call 2 days. But if you go and see, you need to go and say, all right, how many durations can I actually crash a particular activity by? And in that particular example, you see, if my normal time is 3 days, and if my crash time is going to be 2 days, then if I make 3 minus 2, it basically tells me that I am able to go and crash that activity, which is activity A, by only 1 period, which is 1 duration. That's what I'm actually able to go and really make the reduction by. If I go and say, all right, activity B, my normal time is 6, my crash time is 4, and then I ask the same question, how much can I go and really reduce that activity? Well, you say, all right, if my normal time is 6 and my crash time is 4, then I can actually go and reduce that particular activity by 6 minus 4, which means I am going to be able to go and reduce it by 2 periods. So my maximum crash time for activity B is 6 minus 4, which equals 2 periods. So I want you to go and look at this box in front of you. I want you to kind of have a pen and a paper in front of you now. And I want you to go and write on that paper maximum crash time for activity A, B, C, D, E, F, and G. And I want you to go and actually make, calculate it like normal time, 3 minus 2 means my maximum crash time for A is 3 minus 2 equal 1. I want you to go and calculate the same for every single activity from A to G. I'm going to give you a few minutes for you to be able to go and do that. Thank you very much. All right, thank you very much for working on that first activity to be able to calculate the maximum crash time. The next thing you are going to go and be calculating is what we call the slope. And the slope, I've basically explained slope here earlier. I said the slope represents a constant cost per unit of time. So every time I'm increasing something or every time I'm decreasing something, how much is it actually going to go and cost me? The cost per period of time. So we need to know per period of time how much something is going to go and cost me. So if I was to go and reduce my project from 3 to 2 days, which is 1 duration, how much is it going to cost me to reduce it every period? So that 1 period, how much it's going to go and cost me. Now there's a formula, and if that's a question in the exam, I usually don't give you that formula because it's a pretty straightforward. You need to know it. The way you calculate the slope, in other words, the cost per period, is you will do crash cost minus normal cost divided by normal time minus crash time. So if I want to go and calculate the slope, how much it's going to cost me every time I'm going to go and reduce activity A, the way that I do it is I do crash cost, which is 70, crash cost 70, minus normal cost 50. So 70 crash cost minus 50 normal cost divided by, okay, what do we do divided by? Okay, divided by normal time. Okay, great. So divided by normal time, which is 3, minus crash time. So minus crash time, which is 2. So you say 70 minus 50, crash cost minus normal cost. 70 minus 50, that's 20. Divided by normal time minus crash time, divided by 3 minus 2, which means divided by 1. So I have 20 divided by 1, means the slope for activity A is 20. So we know that the maximum crash time is 1, and which means we can only crash it for 1 period at a time. And we know that the cost is going to go and be 20 every time I'm going to go and actually crash it. So what I want you to do now, I want you to calculate the slope for every other activity, B, C, D, E, F, and G. I want you to calculate it now on a pen and paper in front of you. And again, once you finish it, I want you to go and actually let me know. Thank you very, very much. So ladies and gentlemen, you know, I gave you the time to be able to go and make the calculation. And I got a few people basically giving me responses, which is great. I was hoping to actually get a bit more responses, but I didn't, you know, get many. But what I'm going to say is, you know, I told you you calculated the normal time minus crash time. That was easy for you guys to do. The other one, I told you we need to calculate the slope, which is how much is it going to cost me every time I'm going to be reducing a project duration. The way that it works is you need to do crash cost minus normal cost. So in A example, 70 minus 50, that's 20. Divided by normal time minus crash time, divided by 3 minus 2. So you have 70 minus 50 equal 20, divided by 3 minus 2 equal 1. That tells me it is equal 20 every time I'm going to go and crash it. So these are the answers that you guys needed to go and calculate. What these answers tells you, to crash A, it's going to cost me $20 every time I crash it. Every time I crash B, it's going to cost me 40. Every time I crash C, it's going to cost me 30. Every time I crash D, it's going to cost me 25. Every time I crash E, it's going to cost me 30. F would also cost me 30. And here it's telling me G, because the normal time is 6 and the crash time is 6, means G cannot actually be crashed. So that's what it's really telling you here. We cannot crash that activity at all. Now, this is an exercise I would like to go and really show you. I want to try to, I'm going to try to go and show you that exercise in a particular manner to be able to go and really make sure I maximize your understanding of that initial exercise before I go and do anything else. So the first thing I want to put for you is all of that, you know, crash time, normal time, and so on. The second thing I want to go and do for you guys is I want to go and show you this particular graph, which is really a very Very important graph. So these graphs are, the first thing I would like to go and show you. Now, when you are asking yourself, what activity can I crash? The first thing you need to go and do, you need to really actually understand the first thing, what activities cannot actually be crashed. So if I was to go and look here, can you guys tell me which activity can't be crashed?
G.
G can't be crashed. That is correct. So what do we do if an activity cannot be crashed? Is we would usually go and we'll usually put a lot. It's not gonna show it well here, but I'm gonna try to put you like a rectangle so that it's gonna show. So instead of basically 6, what we'll basically put, we'll see, I can put a line between okay, so what I would usually do is I would go and put a line, and I'll put a line over that. What this basically says, it says that, that activity G cannot actually be crashed. So that's the first thing I'll go and do. The next thing I'm going to go and do is I'm going to calculate the total, all the total normal time. So can you please add up all of these things for me now? Just add them up, 50 plus 80, all the normal time. I want you to add them up. That's the second thing you do.
$450.
450. Okay, so that's great. And now the other thing I would like you to go and do is I want to show you this other thing, ADFG. So if I was to go and make these a bit bigger for you so that you guys could see it, actually 30. Okay, you can see here, guys, to be able to finish this project, we have 3 pathways. There's A, B, E, G, A, C, F, G, and A, D, F, G. So I want to ask you guys, can you count A, B, E, G? 3 plus 6 plus 8 plus 6 equal how much?
23.
23. And what about the second path?
14.
Second path.
So not 14.
A, C, F, G.
Oh, the one.
6 plus 5, 11, plus 10,
24.
21,
24. 24.
And what about A, D, F, G?
25.
25. Okay. So let me ask you, which one is the longest?
ADFG.
ADFG. So if my project is going to be, I'm going to put it here on this side. I know that if my project going to be 25 days, what is the cost if my project is 25 days?
450.
What did you guys count for me here? The normal time. What did you guys count? The normal time.
Total 450.
50 plus 80 plus 60 plus 50 plus 100 plus 40 plus 70.
450.
What did you guys tell me equal?
450.
Yes, we shared it as 450, correct. So we know then for the normal duration of 25 days, it is going to cost me $450. The next thing I need to do after I know what it's going to cost me is I need to choose one activity to go and reduce. Do I choose an activity to reduce on the shortest path or the longest path? If I want to reduce my project duration, do I reduce the longest path or the shortest path?
Shortest.
Longest.
What do you think? If you want to finish quicker, which one do you do? The shortest or the longest?
23. Shortest.
Shortest, sir.
Farouk, what do you think? Ramesh, Tasmia, Shristi, what do you guys think? If I want to finish my project quicker, what do I actually go and reduce? Do I have to reduce the shortest duration or the longest duration?
I think
The-
longest, sir.
The longest. That is correct. Thank you very much. So if the longest, we know that ADFG is the longest. So we need to try to see, do we reduce A, do we reduce D, do we reduce F, or do we reduce G? Which activity can't be reduced?
Z.
Which activity we already found that we can't reduce it? G, that's correct. We've done that. So what do? We can actually go and make a we can just kind of we can make something like this. Say, okay, that can't be reduced. You can make the same thing here and say that can't be reduced. And you can make the same thing here and say that can't be reduced. So we need to go and find something else. So we need to decide, do we reduce A, do we reduce F, or do we reduce D? Can you guys see A, D, and F and tell me which one is cheapest for me to reduce? Is A cheaper to reduce, D cheaper to reduce, or F cheaper to reduce because it is on the longest path? A, that's correct. So we're going to go and say, all right, let's go and do this. We make something like, if you want to write it, you could write something like this. You can write A divided by 20. Okay, or you can say crash A, cost equal, 450, which is my original cost, plus an extra $20 because if I'm going to crash, I'm going to be crashing that particular activity. So you basically say something along those lines. I'm going to go and crash activity A, because, between A, D, and F, it is the cheapest. So you crash A, you say, okay, then if I'm going to crash A, the project is going to cost me the 450 plus an extra $20 that I've already calculated. One other thing you need to go and bear in mind, if you crash A, you cannot crash it more than once. So you have to basically put an X to say that I can't crash A anymore. And instead of actually having, 3 here, you'll basically say, all right, it's not 3 anymore. It's going to basically go and be, 2. You say it's going to be 2X. So you're going to say 2X because I can only reduce that duration by 1 time. I can't reduce it further. So you put here 2X, and that means I can't crash A any further. So what I've done is, the first thing is I've added the 20 here. Then I've showed that I've reduced that 20 from that side. Then I've basically changed this 3 to say I can't crash it anymore. It's now 2X, which means the X means I can't crash it anymore. So I've crashed one activity. Now let's go here. If I crash this activity, I want you to go and tell me what would the duration be for A, B, E, G? Did that duration reduce, increase? What's the duration of A, B, E, G now? Anyone? A, B, E, G, 6 plus 8 plus 6 plus 2. Yeah, that's 22. That's correct. And then let's go and talk about the rest. So what about A, C, F, G?
$23.
Okay. So we're going to have A, B, E, G is going to become 22. We're going to have A, C, F, G is going to be 23. And A, D, F, G is going to be 24. Now, guys, that's me now. Which pass is still, one more thing needs to happen here, actually, because A can't be crashed anymore. We have to put here to show that A cannot be crashed anymore. So put an X next to it to say, all right, we can't crash that. It's basically going to be gone. We can't crash it. Now, let me go and see again. Let me ask you guys, which pass is still the longest? Which pass is still the longest?
Last one, ADFG.
All right, I'm having an answer is ADFG, correct. And now, if I'm gonna go and look at ADFG, which one do I crash? D or F?
D.
All right, yep, that's correct. We're going to go and have to crash D because D is the cheapest. So we're going to go and say something along those lines. Let me go and crash D. And what is my cost going to be? If I'm going to go and crash D, what's the cost going to be? Fill those fields for me. What do I put here? The last cost was how much?
$470 plus
So after I got to
25.
20, after I got to 24 days, we know that it was $470. Now, if I'm going to go and crash D, what do I do?
470 plus
495,
25.
that's correct, which means 470. The 470 we've already, had here. That's 470 plus the crash of D, which is the crash cost is 25 plus 25 equal 495. Now, we know that for D, we can crash it how many times? 4 times. So the first thing I'll do is I'll basically put here, instead of putting a 3, I remove the 3 and I put, instead of that, instead of 4, I put 3. So that's a 3. We basically put that 3 here because now it's gonna, I only have 3 more times I can crash it. And if I'm gonna go and look at activity D here, I'm gonna go and take that X out. I'm gonna say, no, it's not 11 anymore. I'm gonna say, well, now it is going to be, instead of 11, I have 10 because, you know, I can keep on crashing it all the way up until I reach 7 days. So I crashed it 1 time, so the normal time reduced. Now, instead of 11, we now have 10 because we've already reduced it by a particular duration. And instead of, if I go and reduce it here by 1, if you go and count, you know, 2 plus 10 plus 5 plus 6, that basically tells you it is 23. So what we'll have now is we'll change the calculations and we're going to basically now have a duration of 23, 23, and then 22, which means for 23 days, we are now having the cost that is actually $495. So you're basically crashing against the one that is the cheapest. And you notice now, because if I go and have here 6 plus 8 plus 6, that's 20, plus 2, 22, so that's 22. 6 plus 5 plus 10, that's 21, 22, 23. And 10 plus 2 equal 12, plus 5 plus 6, that equal 23. So we now basically get to the cost of 23. Now, let me ask you a question. Do I now crash? Where do I now crash? Do I crash on one path consideration, or do I crash on more than one path? Where do I actually crash? Where do I crash now, guys?
F.
Okay. Why F?
Because it's on both paths here.
Exactly, because if I'm going to go and do C by itself, if I'm going to go and say, let me get the cheapest between C and F, you can say, all right, C or F, okay, 30, 30, they are the same. If you're going to go and say D and F, D and F, D is cheaper. So if you're going to say, I'm going to do C and D, 30 plus 25 equal 55. But if you do F, which is on both paths, it's going to only cost you $30. So it's going to cost you much more cheaper to be able to make your crashing than actually crash either C and D or F and D. It's basically F is on both the actual field. So I go and crash F. How many times can I crash F for?
One,
One time. That's correct. So instead of one, what do I put here?
0.
Yeah, well, 0, correct. But what I can do is I can put an X to say, all right, now I can't crash this anymore. What do I put here?
4.
4.
No, not 4. I put something else.
Ah,
I need to tell myself that I can't crash it anymore. So I put 4 and X next to it so that I know that I can't crash it anymore. Does that make sense?
yes.
Now I say, all right, I say I crashed F. The cost is $4.95 because we'll pick it up from here. $4.95 plus an extra $25. No, F, sorry, was 30. An extra 30 equal 525. So you basically see that I crashed it. Now can you just count the durations for me, guys? Count the durations again. How much is this pass now?
$22.
How long is the first pass?
22.
A, B, E, G.
22.
So A, 2 plus 6, 8 plus 8, 16 plus 6, 22. So it remains 22. A, C, F, G, 6 plus 4, 10 plus 10, 20 plus 2, 22. And this one is 10 plus 2, 12, 16, and 6, 22. So for a duration of 22 days, how much is my cost?
525.
Yeah. So what's the cost for the 22 days?
525.
That's correct, 525. A job well done, guys. Now let me now ask you, we know we can't crash F anymore, it's gone. So this is gone, this is gone, and this is gone. Actually, we don't have now, sorry, there's not F up there. All right, now, to be able to reduce my project duration, guys, what do I need to crash? Do I need to crash activities on ADFG, yes or no? Do I need to crash any activity on ADFG? Okay, actually, the only way you can reduce your project duration now is if you are reducing one activity from each path. If you reduce this to 21, but these are remaining 22, the project is still 22 days. If you reduce this to 21, but these two are 22, the project is still going to take 22 days. The only way you can reduce a project duration to 21 days if you reduce one activity per actual path. So the first thing that is easy, we know that D is the easiest because there's only one activity. So you say crash D plus crash, we need to crash C because that's the only one I can crash, plus crash C plus one more I want to crash. Okay, well, we said we're going to crash D, we said we're going to crash C. There's one more, either B or E. Which one do I crash, B or E from the third path?
E.
B or E?
E,
And why?
Low cost is
because
Yeah,
it's budget.
because why do we crash E?
cost is lower.
Yeah, it is the lowest cost. So now we're going to go and say, all right, the cost is going to become, well, we know it's 525. Plus, we know that D is going to be, how much is D? D is 25. Plus, we know that C is going to be 30. So plus 30. Plus, we know that E is going to be 30 plus 30 equal. So that's 550, 550, $610. Now we basically reduce it to 610, but there's more that I need to do. Instead of 3, I need to put this as a 2. And I need to basically, instead of 10, I need to make sure that that's an X. Sorry, not an X. Need to make sure it's a 9. And I know that C can only be crashed once. So I need to go and show that that can't be crashed anymore. So I'm going to have to put something here. I'm going to have to put something here to say we can't crash C anymore. And I have to go and put something here to say I can't crash C anymore. And instead of 10, I'm going to put a 9X for C because I can't crash it anymore. And finally, for activity between B and E, I have to go and said, okay, I crash E. I can only crash E. I can crash E twice. So I'm going to go and put here instead of 2, I'm going to put here that it's going to be 1. And I'm going to go and instead of 8, I'm going to go and put here, I'm going to put a 7 because I can still crash it. I can crash E actually for 2 times. But then when I go and I want to go and add my calculations, I can see now that I have this first pass becomes 21. The second pass becomes 21. And the third pass becomes 21. And I know that my cost, for 21 days is going to go and become $610. Now, let me ask you a question, guys. Can I make any further reductions here? Can I make any further reductions? What do you think? Yes or no?
We can still crash B.
To reduce, we need to reduce 1 from each path. Can we reduce 1 from each path? We can't because A, C, F, G is already crashed completely. We can't make any further crashing. Even if we crash B or E or D and we reduce them to 20, the project will still gonna go and take 21 days for it to go and actually be completed. That is really that particular calculation that is really here. You notice that initially we have 450 because the overall normal cost is 50. You can see that G, we can't crash it, so we take the line off. We can see that we do A first, and we can see that instead of 3, we're going to put 2X, and we can see that we're now going to go and have a duration of 24 days, and the cost going to be 470. Then after that, we see, all right, what am I going to do now? And we say, well, next we are going to go and be crashing another activity. So you go and choose to actually crash activity D to 10 days. It basically brings us to 23 days and then 495. So you can see that's basically aligned directly to how we were basically doing those calculations in OmniGraffle. Then you can see we've done F. And the reason why we did F here is, we've done here the D, but then after we need to go and decide what do we do next. So we do F. So F basically becomes, gone. We do here 4X. And the cost again becomes 495 plus, we increase it to 525. Plus we then need to go and decide one from each path. And that's basically going to bring our cost to 510. So that's exactly what I've basically been explaining for you, step by step, how we go and really do it. You need to kind of count every path. You need to really know, and you need to look at every single path, every single duration, and try to understand which activity am I going to be reducing at any particular point of time. It's very, very important you do that slowly. Otherwise, you won't be able to get it correctly. This is an exercise that people tend to find challenging. And this is an exercise where if I give it in a midterm or final exam, students don't do well. So it's very, very important you guys practice those exercises. When you go and have all of that information, you'll be able to look at, okay, what's my direct cost and what's my indirect cost? In those exercises, we usually do give you the indirect cost ourselves. But when you go and actually add the direct and indirect cost together, you can get the total cost. And to be able to know which project duration is the best for us to go and do, you basically go and usually go and choose a duration that is the cheapest by combining both the direct and an indirect cost. So the 525 plus 250 equals 775. That is actually the cheapest for us to be able to go and do. Anyone have any questions for me, guys, on that one? Anything unclear? This exercise can only be done step by step. Any question at all? All right, so guys, if you can see here, 22 days, 525 direct, 250 indirect. Okay, 22 days, 525 direct, 250 indirect, and you can see the total becomes added as an optimum. So when you want to draw them, you draw a line duration, a cost line. You put, okay, what's my direct cost and indirect cost, and what's my total cost? You combine the direct and indirect cost together. Look here, this is my direct cost, this is my indirect cost. When I combine them together, I get that total cost. So when you draw it, you can easily see which one is going to go and be the cheapest at that particular point of time. Now, ladies and gentlemen, we're going to now start and give you some exercises to go and work on to be able to go and apply what we just taught you. So I'm going to give you time to be able to work on those exercises now. All right, guys, so for anyone who's actually struggling with that first exercise, I would like to go and try to help you and give you the guidance. The first exercise basically is this exercise here. If you go and open it on the system, you'll be able to go and see it. You're basically given a table with a slope and maximum crash time, and it's given you things already drawn. What I want you to bear in mind is if I'm going to give you a question midterm exam or the final exam, it doesn't necessarily mean that I'm going to give you this already drawn, and it definitely won't have the slope and the maximum crash time already calculated for you. You will need to be able to go and do these things yourself to be able to go and really get that response. So that's something you need to go and actually bear in mind. So what I'm going to do is I'm going to just show you how we're going to go and work on that exercise to be able to go and think about it. The first thing we're going to go and do is we're going to calculate the overall, we're going to look at how many passes do we have. That's the first thing I want to do. So we know we have a pass of ABDF. How many days is ABDF, guys?
12.
I need you to speak to me live. I can't, we don't want to waste time because there's a lot to go through today. So I want you to go very quickly and tell me ABDF, how much is it? I need the responses
12.
very quickly. I want to hear them.
12.
ABDF, what's the duration?
12.
Come on, guys, please help me out.
Can you hear me?
Giovanna? I can't actually hear you. No. Are you guys Is anyone speaking to me and I can't hear them?
I am. Can you hear me?
Anyone else speaking to me and I can't hear them? Javan, do you want to try again?
Can you hear me?
Okay, so sorry, I can't hear you, Giovanna. Shristi, can you try to speak to me, please?
Yes. Can you hear me? Hello.
I can hear you, Srishti and Giovanna.
Yeah, I can hear. I can hear you. Giovanna, do you want to try again?
Hi.
Okay,
Can
I
you
can
hear
hear you
me?
now. Yeah, I can hear you. I don't know why it's.
Can you hear me now?
Yes, I can hear you. Great. So please let's just try to get the information very quickly. So ABDF, what's the duration?
12.
Okay, so ABDF,
10.
10 days, and ACEF,
12.
12. Okay. And the second thing I would like you to go and tell me, let's go and look at the cost. What is the normal cost? $1,000. That's correct. So we know for 12 days, so 12 days, we know it is $1,000. Okay. Now we need to decide what are we going to be crashing. Okay, so we already have the slope, we already have the maximum crash time, and I need you to bear in mind that this won't be always given to you. You probably need to calculate that if I was to give you that in an exam. But let's go and look. Which one is the longest?
ACEF.
ACF. Okay. Now, can you tell me first which activity cannot be crashed?
F.
F. Right. So we know that F cannot be crashed. So I'm going to put here something here that we can't crash it. So, and I'm going to also put this here to say that I can't crash F so that we very clearly know that this can't be crashed. So I can only crash either A, C, or E. Which one am I going to crash?
A.
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 Why A?
Because it's in both paths.
Well, no, because it's the cheapest.
Cheapest, yeah, 50.
Between
Yeah.
A, C, and E, it's the cheapest. We need to look at the cheapest. So crash A, costs equal. So we know the cost equal. We know that it's $1,000 plus what?
50.
Plus what?
Suppose it is like, even if we have like common and if it's more in cost, can we cross it or like we will choose the lowest cost?
You always choose the lowest cost. If it's common and the lowest cost, you will choose the common that is the lowest cost. But you always choose the lowest cost. Okay. For example, this might be common, but it might be much more expensive than crashing B and C together. So what would you do? You'll do B and C because they're cheaper than crashing A, which might be much more expensive. Is that clear?
Yeah, makes sense.
All right. So 1,000 plus what?
Plus 50.
Plus 50 equal 1,050. How many times can I crash A?
1.
1. So I know that I can't crash it anymore. I'm going to put an X here. I'm going to put an X here. And I'm going to come, instead of putting 3, what am I going to put instead of 3?
2x.
I'm going to put 2x. So this becomes here 2x. And I need to come and see now what duration do I have now? I crashed A. So how much is the total instead of 10 and 12?
9
and what?
and 11.
9 and 11, correct. And I want you to tell me for 11 days, how much is my cost?
1,050.
1,050. Okay, great. So we've already went and we crashed F. We crashed okay. We crashed F. We crashed F. And I know we crashed A, and we crashed A. We can't crash it anymore. So what do I crash next? What do I crash next?
D.
Okay, remember you have to always crash an activity that is on the longest path.
E.
Okay, C will cost me 60 and E will cost me 70. Which one do I crash?
C.
C,
C.
because C is cheaper. So I'm going to go and say crash C. Cost is going to be 1050 plus how much?
60.
Plus 60 equal how much?
1,000.
110. Okay. Now, how many times can I crash C?
Two time.
2 times. So instead of 2, what do I put?
1x.
No, not 1x,
sorry,
because you can
0.
crash it one more time.
Three.
So instead of 2, you'll put 1 because you can crash it one more time here. And on the other side, what you do instead of 4,
Three.
you basically put a 3. So this becomes a 3 here. And if you count the pass, can you please tell me how much is the, what's the figures now? So A, C, E, F becomes 10.
10 and 9.
And this becomes 9. And if I was to go and ask you this question, for 10 days, what is the cost?
1110.
1110. Okay, great. Now, let me ask you again, what do I crash now?
C again.
See, again, that's correct, because that's the cheapest. So it becomes 1110 plus 60 equal 1170. And if I go and look here at C, I know I'm going to move from 1 to 0. I can't crash it anymore. And I can put, if I want, an X on top of that. And I can put an X on top of this. And I will put 2x. And I will say now the duration is going to be equal. I'm going to just change that. I'm going to say it's going to equal 9. It's going to say equal 9. And I know that the duration becomes 9 days for how much? 1170. Does that make sense?
Yes.
Yes.
So I cannot crash C anymore.
C.
It's gone from the equation. So to be able to reduce my duration now, what can I reduce?
D and E.
Do I reduce one from this path or from the second path?
Both.
What do you think? If I reduce on this path, would I reduce the project duration? Anyone? If you're speaking to me and I can't hear you again, please
we
tell
need
me,
to read
message me.
crash D and E together.
Shrishti, are you speaking to me by any chance?
Yes.
Okay, she is. All right, so let's just try to change this. Can you try to speak again?
Yes. Can you hear me?
Yeah, I don't know. I think
Hello.
this machine is not working. That's probably what's happening. That's why I can't hear you guys. Can you hear me now?
Yes.
Yes. I can.
Hello?
Yes.
Can you?
Okay. Right, let's continue this way. Guys, what do I crash now? Do I crash one from each pass or from one pass only?
From each.
From each
Both.
pass, that's correct. So we're going to crash. We know that for 100%, we need to crash. We know 100% we need to crash activity E. So what else do I crash? Crash E plus crash what?
D.
What's that?
G.
D.
Okay. We said E, that's done, but then there's either B or D.
D for data.
D will cost me correct. So crash D. So equal cost is 1,170 plus the E will cost me 70
70.
plus CD will cost me 60. So plus 60 plus 70 equal 1,300. So if I want to go and do D, D becomes here. It becomes a 2. Sorry, it becomes a 1. And I go and that D here becomes a 2. And I know for a fact that E can only be crashed once. So this becomes a 0. And I know that E becomes this becomes 3x. And I know that I can't crash E anymore. This basically goes. And I know that the duration will reduce E to that becomes 8 days. And this one becomes 8 days. My duration here becomes 8 days equal $1,300. And you can see that I can't crash anymore because even if I reduce this pass, but I can't reduce this, the duration won't reduce any further. So that's the maximum I can reduce in this particular example. Does that make sense?
Yes, it does.
Okay. So that's basically one example. I'm gonna go and try to go with you guys onto one more example. We don't have time for all of them, but I'm gonna go through one more example for you guys. Now, obviously in these calculations, you see a lot of times here, we're giving you the maximum crash time, we're giving you the slope. I will tell you from now, the exam won't give you any of that, or in the majority of the times, it won't give you any of that. So you would need to go and learn how to make those calculations, same as what I showed you here, okay? You need to basically learn to make your calculations like I showed you in this example. You must calculate this. You must calculate the maximum crash time. You must calculate the slope. So make sure you're actually learning that because that's basically what I always will go and ask you if I'm going to go and ask you this question in the exam. So let's go to this other exercise. I'm going to give you one more example, and I'm going to try to guide you again through it. It's again, you know, exactly the same as this first exercise. I'm going to
sorry, for in the midterm exam, like we need to show all the process or just?
Well, no, but if you, well, I always tell you, show the workings. So you need to kind of show me, you know, things like, okay, things like, you know, this, yes, things like this, yes, you need to show me. You need to tell me what you're crashing. So I need to see what you're crashing every period. I recommend you do this workings, not for me, but more for you, because if you don't do the workings, my experience is students will then make a mistake. So my advice to you, although you don't need to show me everything, you need to show me this and you need to show me this. Although you don't need to show me everything, I recommend you do the workings so that you don't actually make mistakes in your calculation.
So we will do in our paper or in the?
Well, okay. In the midterm exam, that's actually a very good question. In the midterm exam, what you do is the best way to do it is the way that I recommend you do it is the following. I recommend you basically write the calculation, only the calculations. Now this workings, I know what you're saying. I just want to try to make it as easy for you as possible. Okay. For your midterm exam, all of this stuff, I will say don't do it. The only thing that I want you to show me is this and this, because you can simply type that answer on the actual system. Okay. For the network diagram that you need to draw, what I need you to do is I need you to draw the network diagram on a paper, take a picture of it, and then send it to your computer, and then upload that picture to your response that you basically went and did for me, because there is an option for you to upload an image, and you'll be able to go and upload that image for a network diagram. For a network diagram, draw it, take a picture, email it, and then save it on your computer, and then attach it directly on the actual exam. Does that answer your question?
Yes, thank you.
No worries. I don't want you to make everything like this, because don't worry about these workings. You make these workings for me. That would be enough for me for this calculation exercise. For the network diagram, you definitely need to draw it, but I'll simplify it as much as I can for you guys. That's why I made this recommendation.
So next week is a midterm.
Yes, next week is a midterm.
At what time? The same time and the
It will be in the class. I think it will be around 4:30, possibly. Just roughly, I think that's where it's going to be.
Okay.
All right. Now, let me go and show you one more exercise. That's going to be the last one. So I'm going to... Okay. I'm going to put all of this here, and we're going to work through that exercise again together, like we work through everything else. Make it as simple as I can. And you still need to go and practice everything else, guys. Like there's no easy way for these exercises. You just need to practice them. It's as simple as that. You don't practice them, you won't be able to really get the right answers for this one. Make it a bit smaller. Let me go and copy some stuff from... All right. Let me just get this ready for you guys. Okay. All right. All right. That's the other exercise. You can see it. I'm going to go through the same thing we've done, from the beginning. So the first thing I want to go and ask you, you can see here, what is the total cost, guys?
1,000.
Yep, that's the second exercise, and it is also 1,000, correct? That's $1,000, we know. All right, tell me how many passes can you see?
3.
Okay, tell me what are they?
Sorry, 2.
What are they?
A, B, C, F.
ABCF equal how many days?
12.
12. And
Yeah,
what's the other one?
13.
Okay, A, B, D, E, F equal 13. So that's the first thing we've done it. So we know for 13 days equal how much?
1,000.
$1,000. Okay. Can you tell me which activities can't be crashed?
A and F.
Okay. So if we say A can't be crashed, if we say F can't be crashed, that's great. We say A can't be crashed, that's great. And we can basically come and put, you know, one here. Okay, so we see A can't be crashed, A can't be crashed, F can't be crashed, and F can't be crashed. So now we need to decide, do we crash B, do we crash D, or do we crash E? Because that is the longest path. So could you please tell me, what are you going to crash?
D,
D. Cost equal how much?
1040.
1,000 plus 40 equal 1,040. Great. So we crash D. How many times can I crash D?
One.
One time.
One time. Okay. So tell me, what do I put instead of here? Instead of 1, what do I put?
0.
0. I can't crash it anymore. And here I put this one here. And what do I put instead of 3?
3.
Instead of 4?
3x.
3x.
Okay, I put 3x. Okay, and then let's go and count the duration. So could you please tell me what the duration is?
11 and 12.
Think again.
Sorry, 12 and 12.
12. And then if I go and say 12 days equal how much is the cost?
1,040.
1,040. That's very, very good. You guys are smarties. I love it. Okay, now we've already done D and we can't crash D anymore. We know that. We need to make sure that we're going to put a beautiful X next on top of that D. So now we need to decide, what do we crash? B will cost me 100. C will cost me 50. And then we go and say B. Okay, so what do we say? Sorry, B will cost me 100.
Crush C
C
and
will cost me 50.
C. C.
E will cost me 40 and E will cost me 50. Sorry, I'm looking in the wrong place. I have B and E, 100 and 50, and I have B and C, 100 and 50. Which one do I crash?
C and E.
Crash C and E.
C and E?
Yeah.
Okay, I'm going to, how much would C and E cost me?
100.
100.
Yeah, you can crash B.
B.
Okay, why would I crash B instead of crashing C and E?
Because you can do once.
No,
I don't know.
that's one reason. But the other reason is because B is an activity towards the beginning of the project.
Okay.
And if you want to crash, you start crashing something that is closer to the beginning of the project if the cost is going to be the same.
Yeah.
Does that make sense? Because
Yeah.
then you can win so much more time later in the project.
All right.
Is that clear, guys?
Yes.
So instead of 1, what do I put?
0.
0. And instead of 3, what do I put?
2x.
2x. And instead of B is going to be totally gone from here. Going to be totally gone from here. And I'm going to say I crash. Let's say crash B. Cost equal 1,040 plus 100.
So sorry. So even the cost is high, but also we will choose B. So like, can you give us a little bit more example for like this condition?
Yeah, that's what I'm telling you. I'm telling you, you can crash C or E, or you can crash B. C and E will cost you 100 and B will cost you 100. So if you have the choice where they are both equal, what do you decide to go and crash? The reason why you crash B is because B is more closer to the beginning of the project. Because if you crash something at the beginning of the project, you will still have much more time towards the end of the project in case something was to go wrong. You might be able to crash these later, but you start by crashing things at the beginning of the project whenever you have the opportunity, if the costing is going to actually go and be the same. Does that make sense?
Thank you.
Is that clear?
Yes.
Okay, great. Now we've already done and we know that duration is going to go and reduce from 12 days to 11 days. Actually, is it 11? Sorry, let me see. We did B, we did D. Yes, it's going to be 11 days for each. So my question to you now, what's the activities that I can crash? How many are left that I can crash?
C&E.
C and E, it can only be crashed once, so I can't crash anymore. 50 and 50, that's 100. So 140 plus 100 equal 1240. Does that make sense?
Yes.
Now, any questions?
No.
All right. All what I'm going to say regarding these is there's need to be much more exercise that you guys need to go and do. I gave you, they are available on the internet. I want you to go and practice them before I go and load any solutions. Actually, you know what? I'm wary that the exam is next week. So I'm actually going to release I'm going to put the solutions for you on the system today, because that will give you a week to be able to go and work through all of these activities and check your answers. But I want to tell you that there are at least 5 more exercises you guys are able to go and do there. My advice to you is make sure you go and work through them. Don't leave them, to try to actually go and have a maximize your learning in that particular information. Does that make sense?
Yeah.
Okay, great. Now, guys, what if costs, not time, is the issue? What can we do if we want to reduce our costs? We can reduce the project scope. We can have an owner take more responsibility to do the job, like I showed you in one of the exercises, a few weeks ago. You can outsource project activities or even the entire project, and you can brainstorm with various people some cost-saving options to try to minimize the problems and try to go and find the cheapest possible cost that we can actually go and get. Now, I want to go and talk very quickly about being an effective project manager. I'm not sure we're going to have time to do a lot of the activities that are in there, but I'll still load all the solutions for you anyway. It's really more relating to being a project manager and about leading people. We're going to understand the difference between leading and between managing a project. We need to understand the need to manage project stakeholders. We need to create a stakeholder map and develop strategies for managing all of these project dependencies. Understand the need for a highly interactive management style on projects. We can talk about how more effectively manage project expectation, and we're going to talk about, understanding the importance of building trust and acting in an ethical manner while working in a particular project. Now, ladies and gentlemen, leadership and management are 2 different things. You lead people, and sometimes you lead people not because you are their manager. Sometimes you lead people because people see you as a good leader in the community. They might not report to you. Like, you're going to have a sports person might be the leader. You don't report them, but you find them. Like Cristiano Ronaldo, a lot of people go and like him. Or you go and see, some great, politicians, for example. People like them. If you go and see, particular, a lot of people like New Zealand Prime Minister. Why? They believe she's a good leader. Now, leader is about leading people. It's about, having charisma, having ambition, having views that allow people to be able to go and want to go and associate with you and go and follow what you basically ask them to go and actually do. You lead people, and then you manage the projects. We need to go and manage the project in an appropriate manner. Managing project is about knowing the technical and non-technical side of things about project management and trying to ensure we are able to go and really get the right outcomes. Now, project managers must be both a leader and a manager. Why? Because we have a lot of risk. Expectations are more specific. The resources are more diverse, and many are not even in your department. We have shorter deadlines. We have no chance to do better next time. We need to lead. We can't just simply tell people what to do. We need to lead by example. We need people to see what we're doing. We need people to want to go and associate with us because they see the value and the benefit of the work that we're basically doing at any point of time within the organization. You need to bear in mind that you can't do everything by yourself. Hands-on work is not the same as leading. You can't just basically go and do the job and think I'm leading people because I'm doing the job. You need to know that what is really important to you is, isn't likely as important to someone else. There's different people, different group, different teams, different agendas, different priorities. And the sooner you understand that people are going to be different than you, the better it's going to be in terms of trying to go and understand those differences, understand people's needs, and trying to go and create an approach for you to be working with all of those various people. Remember that project management is tough. It is, however, very exciting. It's very rewarding. And you need to go and really persevere to be able to go and really reach the right outcomes. And you need at any point of time to work with so many various stakeholders who, by working with them in an appropriate manner, you are actually able to go and really achieve the outcome you would like to go and really achieve. So I'm going to go and really show you an example. If you go and look here, you see that you will actually go and deal with so many people in the course of actually going and delivering projects. Those people you're going to go and deal with are all your project stakeholders. You need to find a way to be able to go and satisfy them all and work with them in an appropriate manner. As a project manager, you are one of the project stakeholders yourself. You're going to go and work with the project team, who are your project stakeholders. You're going to go and work with project sponsors. You're going to go and work with top management, customers, functional managers, admin team, project managers. All of these might be working in your organization, but you might also be working with people outside your organization. Contractors, vendors, government agencies, other organization, they all have a stake in your project, and they want you to go and work with them in an appropriate manner to be able to ensure we are going to deliver the jobs that is really needed. Now, this is an activity I really encourage you to go and have a look at. We're not going to have time to go through them. We're a bit tight on time because we spent a lot of time to ensure I guide you on the calculations, but that's fine. Think about, you are an organization, you are organizing a concert in your hometown that will feature local heavy metal rock groups and guest speakers. Draw a dependency map identifying the major groups of people that are likely to affect the success of your project. Could you think about someone who will affect the success of your project, guys? Who will affect the success of your project? Can you think about anyone? You want to make a concert in your hometown? Who would affect the success of the project?
I don't know how to answer that.
What's that?
I don't know how to answer that.
Well, you are making a concert. You want to make a concert. You want your concert to be successful. How would you get that success? Who you need? Who are the people you need that will help you ensure that that project is going to be a success? If you don't have the band, is that going to be a success?
No.
Okay, no. If you basically not going to get the support of people in your community to be able to go and do that project, is it going to be a success?
No.
If your team members don't do their job, is it going to be a success?
No.
So all of these are dependencies you need to go and really bear in mind. These are people you are going to be relying upon to be able to go and really try to ensure that the project is going to go and be successful. You need to go and think about, do you think, people will be most cooperative? Who will be most cooperative? Would the local mayor be very cooperative because he's going to get a lot of more money? Would the neighbors who are going to be affected by noise be not cooperative at all? Because you need to think about them. Once you know who will be cooperative, once you know who won't be cooperative, what are you able to do? You are able to then take the action that is required. You'll be able to go and find, how am I going to go and actually make sure that people who are cooperative, I'm going to make sure they are going to remain cooperative, and people who are actually not happy, I need to go and understand why aren't they happy, and you need to understand what am I going to be making to be able to make them more cooperative. So that's a sort of activity I'm putting there that I encourage you to go and work through it a bit later when you have time. You need to bear in mind how you can influence people. There is a law of reciprocity. You know, if I go and help, you know, Farouk today, or Giovanna, or Fidak, or anyone, if I go and help you guys, what are you going to in return? Is he going to go and actually help me? If I go and I am bad to you and I don't help you and I'm terrible and I'm not supportive, and what's going to happen? You're going to be the same thing. You're not going to go and help me. You're not going to be kind to me because I'm not actually kind to you. It's just the same way it works like this. Another thing to bear in mind in project is the quid pro quo, mutual exchange of resources and services. You scratch my back, I scratch yours. Sometimes you might need someone in the project. I go and say, oh, no problem, have those people. No problem at all. And then after, what's going to happen is you might have the same thing. You want to get the same support. So what's going to happen then? What's going to happen is you're going to go and you're going to say, oh, you helped me last time. You gave me that resource to go and help me. I'm going to go and help you now. You exchange with me your resource. I'm going to go and exchange with you mine. There's a lot of what we call, currencies. Cooperative relationships are built on the exchange of organizational currencies. If I, for example, grow your career, that's going to go and you're going to find that as a currency. Like you say, oh, this guy's helped me to grow my career, I'm going to help him. If you're going to go and find that, for example, you need friendship and I'm helping you, that's great. If you see that you would like to go and have work flexibility and I'm helping you, that's basically become like a currency. I'm basically winning because you can see that I'm actually helping you. And as a result, you want to go and help me in return. So that's the sort of currencies you need to think about building when you're basically working with other people and other stakeholders. You need to understand what other people want, and you can give it to them, and you would need to understand what do you want and what you can get from other people if you are actually acting with those people in an appropriate manner. You need to really build a network of dependencies. Let's go and look at all of these people around me. Let's look about the project perspectives. As a team, whose cooperation will we need? As a team, whose agreement or approval will we need? Whose opposition would keep us from accomplishing the project? But you also need to go and look at all the stakeholders. What differences exist between the team and those who the team depend on? If you depend on those people in the community who wants to go and have all of this quietness in their community, what is the difference between you and them? You want to go and do the concert, there's a difference. They don't want any noise. How are you going to go and really target them to ensure that they are going to give you the support that is really needed? How do the stakeholders view your project? Do they support it or do they not support it? What is the status of your relationship with stakeholders? You might have a very good relationship and they're very willing to go and support you. And you might have no relationship at all and they're not actually willing to go and make any support at all whatsoever. What sources of influence does the team have relative to the stakeholders? Okay. So how can you go and really influence all of those people who are the project stakeholders? You need to try to build all of these relationships. And one very good way to be able to go and do that is what we call management by wandering around. It involves managers spending time, and the majority of their time, in face-to-face interaction with employees, building cooperative relationship. You want to build relationship with your team, with other departments, with other stakeholders. A lot of time, project managers, the job they do is they do management by wandering around. They walk around, they speak to people, they try to make sure they're trying to give the support to all of those various people. Now, what are the characteristics of project managers who are good project managers who can get the job done? They initiate contact with all the key players because they actually spend the time to identify them. They know who the people they need to support, and they basically speak to those people and they build all of this relationship. They anticipate potential problems. that could really go and inhibit progress, and they try to go and deal with all of those problems. They encourage all the people, all the team members to be able to go and get the job done. They reinforce the objective and vision of the project and making sure that other people know about it and try to go and get the support. And they basically find whenever there's a conflict between various people, they go to resolve the conflict. Whenever there's an issue, they go very quickly to be able to try to go and find a solution for any particular problem. You need to manage what we call an upward relationship. So your project success, if I am an IT manager, my project success is basically a lot of time dependent on whether I have senior management support. If I'm a project manager, I need to potentially to get the support of the chief technology officer in my IT department. The chief technology officer needs to go and get the support of the finance manager, needs to go and get the support of the CEO. So we need to try to go and understand how can we go and achieve the success. And a lot of it is about, let me manage all of my relationship. Specifically, let me manage my upward relationship, my relationship with all of my top management. If I do that, and if I need money, they're going to ensure I have the right money. They're going to be responsive to my needs, anything expected and unexpected. They're going to provide a clear signal to everybody in the organization that it is important for you to cooperate with that project manager to be able to ensure the job basically goes and gets completed. Another thing that is important to do is to motivate the team members to get the job done. So let me go and look about all my team members. Let me go and see what they need. Okay. Let me go and influence all of these senior management to actually making sure they are going to be supportive for my team. If they come and ask for things that are unreasonable, I get them to go and change their requirement. If I need more resources, I'll speak to them to get more resources. If I want them to go and recognize all the hard work that my team is doing, I want to go and make sure that they're going to spend the time to recognize all the accomplishment of the team members to be able to go and ensure they get the job done. Now, a lot of times we are dealing with ethical issues in project management. And it's many times difficult for us to bear in mind what is right and what is wrong. The thing that you will see in a project environment, padding of cost and time estimation. People know something's going to cost $100 and they quote $200. They know it's going to finish in 1 day, but they quote 2 days. That's one ethical situation that you must be really looking at in terms of how you're working in a project environment. Exaggerating how much money a project is going to actually go and generate is one other big issue that we tend to go and experience a lot of times. So, something's going to go and really earn a lot of money, but in reality, it is not going to actually be earning anything close to what basically is expected or anticipated for us to go and really think about. Falsely assuring customers that everything is on track and hiding from them the issues that show that something is not working on a timeline that I expected. That's another issue we want to avoid. We don't want to lie to all of those stakeholders. Being pressured to alter status reports to show that things are on track while they are actually not. Falsifying the cost accounts, how much things are costing us. I've seen one environment where there was a construction company. I was really shocked when I saw it, but it was a construction company, and what the company did is they had a client who wanted them to go and build a building for them, and the agreement with them was, we're gonna basically charge you for the cost of the project plus an extra 10 or 20%, whatever it was. But what I was surprised to see is the builder was getting quotes. So let's say they get a quote for a plumber. Let's say the plumber says, I want $500,000. They go and put the quote as $500,000 for their business, but they go and actually charge. They get that that person who's given the quote, they get him to give two quotes, one for 500,000, one for $1 million. The $1 million goes to the actual client who requested building the property, and the 500,000 is the actual contract for the builder. So the builder was actually charging the person an extra 500,000 more than what he should charge him for one particular job, let's say plumbing, although the contract says you can only charge him on top of your costs an extra 10% or an extra 20%. So instead of charging $100,000, they were charging $500,000 extra because they were actually falsifying the accounts and the numbers for them to go and charge a client more money. That's not ethical. That's a wrong thing. You can't really go and do that. Being pressured to alter status reports, ensure everything is progressing well. Falsifying cost accounts. It happens a lot in real life, and that's not ethical. Compromising safety standards to accelerate progress. Approving shoddy work. You might have heard about 2 or 3 years ago, people were evacuated from one very big building in Sydney Olympic Park on, I think, Christmas Eve or Christmas Day or something. And it was all of these issues they found in the construction of that property, in a shoddy work. They had to spend so much money to be able to go and fix that building. It wasn't really a very good outcome. You need to bear in mind about the code of standards. You know, what is the code of conduct we need to follow? What are the standards that are acceptable? You need to ask yourself what is right and what is wrong, and how should I go and be dealing with all of those people by acting in an ethical manner and ensuring I don't falsify anything, and I always go and really do the right thing, and there's no lying at all in any of the information that I go and really do. That's another activity you could, we could maybe, let's look at the time. Let's spend the time doing this activity, guys. I want you to read it and think about it. You are driving to a project status report meeting with your client. You encountered a significant technical problem on the project that has put your project behind schedule. This is not good news because the completion time is the #1 priority of the project. You are confident that your team can solve the problem if they are free to give their undivided attention to it, and that with hard work, you can get back to schedule. You also believe if you tell the client about the problem, she will demand a meeting with your team to discuss the implications of the problem. You can also expect her to send some of her personnel to oversee the solution to a problem. These interruptions will likely further delay the project. What should you tell your client about the current status of your project? I want to give you a few minutes to go and think about that individually to try to start giving me some of your responses for that particular question. So I'm going to give you, think about it for the next 2-3 minutes and let me know how you would believe we can solve that particular issue. All right, guys, what do you think? Would you tell the client? Would you not tell the client? And why?
I think you should tell the client.
Why, Giovanna?
I think you should tell the client.
Why?
To keep it clear, I don't know.
But I'm going to solve the problem.
But it's going to delay the project.
Yeah, but I'm confident my team is going to be able to solve it.
Yeah, I don't know.
What do you think?
I think,
my team is going to solve it. I think they're going to solve it.
but what if they don't?
What if they don't? I don't know. Come on. Why are you bearing all the bad news for me? Seriously, I'm going to solve it. What do you think? Who else? Tasmia, would you tell the client, not tell the client?
Sir, I guess I will ask for some time more.
You'll ask for more time? So you will say, look, we're having some issue. We want more time. Is that what you would do?
Yes.
Okay. So you would basically not hide it and say, you know, everything is okay, everything gonna be all right. You won't hide it? Who will hide it?
Me, sir.
Why would you hide it? Mohammed?
Hello?
Sir,
Yeah, go
until
on.
and unless I'm confident about it,
You're
like my
confident.
team can do it, then why I need to take more tension by telling the problem to the client? Client should be worried about the time, and if I am confident I will give it on the time, then I should not give them or my team extra stress.
Okay, Mohammed, I'm gonna ask you a question.
Yes, sir.
Do you remember December 2019, specifically 31 of December 2019?
Not sure.
Okay, what happens what happened on the 31st of December 2019? What happened? Anyone?
What happened? I'm not
Yeah.
sure, sir.
31st of December. What happens on that night?
Fireworks
Fireworks. It's a New Year's Eve.
celebration.
Okay, so Mohammed, I want to ask you another question.
Yes, sir.
On New Year's Eve, 31st of December 2019,
Yeah.
what did you hope for?
What did I hope for?
Yeah,
Obviously, the better future.
you said 2020 is going to be a great year.
Yeah. Obviously.
Yes?
Yeah.
And what was it?
Lockdown.
It was a scrappy blah, blah, blah. Okay, so my question to you, Mohammed, if you don't go and tell the client because you're confident you are going to be solving the issue,
Yes, sir.
and something like the coronavirus hit, you don't know, something just appeared out of nowhere.
Obviously, sir, but for the time being, if I'm confident, then I should not worry about the future, what is going to happen in the future. If I will take worry about the future, then I cannot do even something good in the present. So
I get your point, my friend, but I think it is going to be a big problem because you are taking a risk there. You are assuming that the job will be done because you're confident. Usually people doing the project are always confident they can solve the problem. Sometimes they can't. And if they don't actually become upfront from the beginning that there is an issue, you will lose your credibility as a project manager. And next time there's a job, they won't employ you because they don't
Yes,
trust you anymore.
yes, sir.
Okay. So that's one thing you need to bear in mind. Yes, you're all right. Everything you said was correct. You know, yes, I might be able to finish it. All of these things are correct. But I need you to bear in mind that this might not actually work well if you basically don't tell them the truth and then something goes and actually goes to occur. Okay.
All right.
If I was you, I would want to protect you from any negative issues. Anybody coming and saying, oh, this guy is a bad project manager or is not telling me the information. I will go and be upfront in my information to ensure that I give no one any chance to go and talk badly about the work that I've done.
All right, sir.
Alrighty, but good views by everybody. Giovanna,
Yes.
thank you very much. I'm happy that you were bearing
It's all
that
right.
history. Great job. Thank you.
Okay.
All right, guys. So there's a lot of contradictions a project manager will need to do. I need to be innovative, but I need to be stable all the time, stability. I need to see the big picture of the whole thing and how my project fits with the whole organization and the whole strategy. But I need to also get my hand dirty and help the people if I need to. I need to encourage every individual to reach his best. But I also need to stress on the importance of the team. I need to have a hands-on approach to get things done. But I need to have a hands-off approach to trust people that they can do the job. I need to be flexible to help people, but firm if there's a problem with people getting the job when I need it to go and be completed. I need to think about the team. I need to be loyal to my team, but also I need to be loyal to the organization. What if my project is no longer needed? Do I remain loyal to the team, although I no longer need that particular thing to go and really be done if my project no longer serving the needs of the business? These are very important things that you should really go and bear in mind. Some suggestions that I really believe they work a lot. Don't go and wait until when you need someone to build a relationship with that someone. You need to build the relationship before you need those relationships. You need to build trust, and that trust is sustained through time, through face-to-face contact. Nowadays, even Zoom contact is still face-to-face, better than phone communication. Realize that what goes around comes around. You help people, you get help back. You bad to people, they're going to go and be also bad to you in return. It's as simple as that. You need to go and really do the right thing. Now, I'm going to go and try to see, we're not going to go and really do those exercises because we're not going to have time for them. But what I noticed is we still have a bit of time to work on some of those earlier exercises. So what I would say is, maybe I'm going to give you time to start working on exercise 3 now. But instead of me doing it with you directly, I'm going to allow you to go and do it yourself now. I'm going to give you 10 minutes now to be able to go and start working on that activity just now. So I'm going to pause my recording. I'm going to give you 10 minutes and then we'll come and we'll see what answers you got before we go and finish for tonight. Thank you very much, guys. You have 10 minutes to work on this activity by yourself this time. Thank you. So I'm going to go and show you that exercise for a minute. So that is the exercise that we show you here. What is the total normal cost that you guys found here? What's the total normal cost? Total normal cost?
$1,400.
That's 1,400. What I will show you is I've tried to upload some manual responses for you intentionally because I want to make sure you guys see the working that I've actually done step by step. So if you go and see on that exercise, you'll notice that, we have 3 passes, 11 days, 16 days, and 8 days. And you notice how I'm actually doing crashing one step at a time, what can't be crashed and so on. The first one we can go and crash is, G20. Why? Because first of all, I need to look at the longest pass, that's 16. I have A, B, D, and G. A, B, D, and G. G is the cheapest, that's 20. And that's still going to go and, that's going to reduce my duration to 15 here instead of 16. And I can only crash it once. Then I can crash either A, B, or D. So you can see A, B, and D. You basically find that D is the cheapest. So that basically will reduce my duration to 14. And then you also know that I can crash D only once. So you can't crash D anymore. And then you have either A or B. So A or B, B is the cheapest. So that basically drops it to, 13. And then we make A, which is the last one I'm able to go and really crash, because you have to always go and look at the longest path to be able to decide what are you going to be crashing. So you notice that I've put the solution for you one by one, what can be done to be able to go and see how we basically crashing any particular information. I encourage you to go and look at that exercise, as well as to go and look at all the other exercises, because I can tell you that this is something that is going to go and be very important for your midterm exam next week and for your final exam. It's always, any calculation I teach you is important. And I've already put the solutions for you guys here for both the different type of question that I'm asking you here, because there's a calculation, non-calculation question that I've included in that tutorial exercise. Any questions at all?
In midterm exam, we will get only calculation or any theory or multiple question as well?
There's 2 calculation exercises, and there's 1 question that is, it's not directly theory. It's more about showing me you understand what I've been explaining for you. It's not necessarily a theory question. It's just much more than just a theory question. Okay, it's about really showing me your understanding about a particular project management concept that I've explained to you in previous weeks. Any other questions? Okay, guys, I want to say, please review the lecture slides, the tutorial materials and notes you've taken. Read chapters 9 and 10, continue preparing for your midterm exam that is going to take place next week. In the class, please make sure you're present in the class from the beginning. I want to remind you that we care about you and about your success. I want to thank you very, very well for all your hard work, all your time, all your dedication. I really appreciate it. Continue working hard and we will be able to go and really reach success. Have a great evening. Thank you very much for coming today.